Hi, welcome to my video on extra problems number 1. Let's prove the identity that 2 times the tan of x over 2 divided by 1 plus the tan of x over 2 squared equals sine. And we're going to use the interval of 0 less than or equal to x less than 90 degrees. And also we're going to use the tan of x over 2 equals this formula right here. So to do that, let's do left side and right side. And the right side is sine x, and the left side is 2 tan x over 2 divided by 1 plus tan squared of x over 2. And we're going to let the tan x equal this formula, so there's tan x right here, and it's positive because tan is positive from 0 to 90, so we get 2 square root of 1 minus cos x over 1 plus cos x, and draw a line, and we get 1 plus tan squared. Same formula, only we have to square that formula. So it's 1 minus cos x, 1 plus cos x, and we're squaring it. So let's simplify this. So inside of here, I should do the conjugate of the bottom. So we got a 2 square root of 1 minus cos x, 1 plus cos x times 1 plus cos x over 1 plus cos x. And the denominator, when we square it, we get a 1 plus, and the square root of this fraction in terms of cosine squared, square root squared is just 1 minus cosine x, 1 plus cosine x. And let's simplify the top, make it look a little bit better. So we multiply 1 minus cos x by 1 plus cos x. We get, I have to do a conjugate here. Now the conjugate of 1, so that's a minus, see? I made a little mistake already, and I know the difference. The conjugate of 1 plus cos x is 1 minus cos x. Now, 1 minus cos x times 1 minus cos x is 1 minus cos x squared. And when we multiply the denominator, 1 plus cos x times 1 minus cos x, that's like multiplying a plus b times a minus b. And we get the difference of 2 squares, so 1 times 1 is 1. And positive times a negative is a negative. And cos x times cos x is cos squared x. And the denominator, we have fractions, so the LCD is 1 plus cos x. So we make the 1 plus, cos x over 1 plus cos x. Because the 1 is whatever the denominator of this fraction is right here, which is 1 plus cos x. 1 is that term, that binomial over itself. Okay, let's continue. And we simplify, we got a 2. So the square root of 1 minus cos x squared is 1 minus cos x. And we have the square root of, right here, we got the square root of 1. But so we can't do that yet because we have to change 1 minus cos x to sine squared x. So 1 minus cos x is sine squared x. And it's when we have the same denominator, which is 1 plus cos x, we add our numerators together. I got to keep that long line there because this is the division. So that's 1 plus cos x, add on 1 minus cos x. Two fractions of the same denominator, so we add the numerators. So let's continue. So we got a 2, 1 minus cos x, square root of sine squared is just sine x, square root of sine squared x is just sine x, all over, and we add these together, cos is cancelled out, so we get a 2 all over 1 plus, oh, that's a cosine, yeah, it's cosine x. Now, we have, so that's 2 times that, so that's 2 times 1 minus cos x over sine x. So that 2 over 1, the 2 goes with the numerator. 1 times sine x is sine x. And now we're going to multiply by the reciprocal. So we're going to multiply by 1 plus cos x over 2. We got two fractions. So this is a division sign right here. So it's this fraction multiplied by the reciprocal of this one right here. There it is. And what do we have? We have the 2's cancel out, and we have 1 minus cos x times 1 plus cos x all over sine x, and 1 minus cos x times 1 plus cos x. Again, that's an a plus b times a minus b, so it gives you a squared minus b squared. So you take the 1 multiplied by the 1, and you take minus cos squared x. So the outside is plus cos x, the inside is a minus cos x, they give you the 0. So the 0 is, so we have the, what we call the a plus b times a minus b, which is a squared minus b squared. And 1 minus cos x squared is sine x squared. And sine squared x divided by sine x is sine x, which is what we need. So notice, excellent problem in relation to this bit of algebra in here. That's why I wanted to go through this. So we make the statement, since left side equals right side, it is an identity. And that brings us to the end of this video. It's long enough as it is, and again, look at the algebra that it takes to work this through. An excellent problem, excellent problem. And if you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.